is on your page, let's see, 6, I believe. This is on your page 6, and it's number 1. On this one, yesterday we looked at the graph and saw where it had maximum, minimum, and concave up and down. Well, today we're going to take a look at this and actually do it algebraically. The first thing we're going to look at would be increasing and decreasing minimum and maximum and critical points. If you remember, we said that all of those focus that I have defined, that I have told you now, has to do with the first derivative. So we have f of x, and we're going to take the derivative of f of x, which is first derivative, to find all of the increasing, decreasing, max and min if they have both, and critical points. Okay, so the derivative of this would be 12x minus 3x squared. Now we know that it has minimum or max. On your graph it looks like something like this. We know that it's going to have a 0 slopes at those points, so what we're going to define is we're going to define the 0 slopes first. So if we define our 0 slopes, everywhere else has a slope, so we can define those as we go along. So we're going to set this equals 0. Now when we do, we're going to have to factor stuff out. If you set equals 0 like this and solve it without factoring it out, you'd lose an answer. So we're going to factor out as much as possible. So I can factor out 3x. When I do, I get 4 minus x equals 0. Now once it looks like this, once it looks like something multiplied by something else, we can set each of them equals 0. So we'll have 3x equals 0 and 4 minus x equals 0. So on this one, my x will be 0 because I divide both sides by 3. On this one, my x will be 4. Now this is what we just found. We set our derivative, which is this, equals 0, which means my slope is equal 0 at that point. So we're saying at x equals 0 and at x equals 4, my slopes are going to equal 0. That's what we found. So at these points, my slope is equal 0, and at this point, my slope is equal 0. So we found those. So we're saying, okay, as of right now, wherever this maximum or min is, one of them is going to be at x equals 0, the other one's going to be at x equals 4. Okay? Now, we have to, as you can see on this example graph, this is not graph of number 1, but on this example graph, we can see that everywhere else is going up, down, and up. So that's what we have to figure out, and we now do that in calculus with number line analysis. So it looks somewhat like this. We're going to draw a number line, and this is going to be a number line of all of your slopes. So this will be your f primes, which are all the slopes. So on my number line, I know that my x at x equals 0, my slope is 0. And at my x equals 4, my slope was also 0. What I'm trying to figure out is what happens in between these. I want to know what happens from after 4, in between 0 and 4, and before 0. The way that we check it is by taking the numbers that's in between and plugging it into my f prime. Now keep in mind, this right here is my f prime, but so is the one below it. We just factored out these two are equivalent expressions. To me, it's easier to plug it into the factored out form, so I'll do that here. I'll do some scratch work as we go along. Now, in between 0 and 4, I know there's number 1. So I'm going to plug number 1 into my f prime of x. So if I plug into my f prime of x, this gives me, all right, 3 times 1, parentheses 4 minus 1, which this is 3 times 3, which gives me a positive number. I don't care what number it gives me, I just want to know what sign it is. Since it's a positive 9, we know in between 0 and 4 we'll have a positive slope, because my slope at 1 was 9. Now we'll do the similar thing again. One after 4, I'm going to take number 5 and let's plug it in. So I get f prime of 5 equals 3 times 5 times 4 minus 5, which 3 times 5 is a positive number, times 4 minus 5 is going to be a negative number, which gives me a negative number. Do you see how I became, like, at first example that I gave you of plugging in 1 to the slope, I plugged it in as it is, but the next one, I just kind of guesstimated what the signs will be because that's all we need. We don't need an exact number, we just need a sign. Now let's do a similar thing here. I'm going to pick negative 1. Sorry. Let's pick negative 1. If I pick negative 1, so f prime of negative 1, slope at negative 1 is 3 times negative 1 times 4 minus negative 1, which gives me negative number times 4 minus negative 1 gives me a positive number that also becomes negative number. So here's what we found. We found that at 0 and 4, I have 0 slopes, but from before 0, it's going to be decreasing, and then it has negative slope. After 0 to 4, it has positive slope, and then it has negative slope again. So if I were to make my best guess, it's going to look like negative slope, positive slope, and then negative slope. That's what my first graph should kind of look like, based on our graph, where this being x equals 0, and where that being x equals 4. So let's write down what we found out. So we know that the function is increasing when it has positive slopes. You see how that's increasing right there? From 0 to 4. We know the function is decreasing from negative infinity to 0 and 4 to infinity, because decreasing and decreasing there. Now as we look, you see how you went from decreasing to increasing? That's when the minimum is there, because you went from decreasing to increasing. That's at x equals 0. And my maximum goes from positive to negative, or increasing to decreasing, and that is at x equals 4. Now, as we know, our critical points are when my derivative is equal 0 and undefined, so that's, you already knew that all before. Those were x equals 0 and 4.